Hi everyone, welcome back to Let's Unbound. So we are in the new episode and we are going to discuss 2.12 in this particular video. So yes, it's logarithmic function manipulation. It's kind of the things we already know and how we are going to manipulate those things, basically the properties, while solving problems in transformations, right? So that is the essence of the topic, this particular subunit. And here we go for what is this logarithmic function manipulation. So logarithmic function manipulation involves law of logarithm, I say properties, right? While simplifying, expanding, and condensing. I hope you remember we did few examples, problems on condensing, expanding, simplifying logarithmic expressions. And also this manipulation can be done in transformation also, or just simplifying a problem, solving a problem, any kind of thing. So let's quickly review properties. Law of logarithm, we have product rule, quotient rule, power rule, change of base rule. Not only this, we have some other too, right? So these are the main basic things. Now, what is product rule? Log with the same base, log ax plus log ay. It's added means you can make it to single log. This is condensing. Log x and the input will get multiplied. What if my log with same basis or subtracted? So log with the same base, we have to divide it x by y. And next is power rule, log with a. If your input is expressed as a power exponent form, you can just take the input and put it in front, like not input. Input's exponent you can put it in the front, right? So this will be helpful in many ways. Then this important one, change of base rule. In our calculator, so the common logarithm will be given, ln will be given. I think that's it. But sometimes we have to solve for log 1 by 2, right? In that case, we should know about the change of base rule, because if I have log 1 by 2 of something, I can't solve. I need to change the base to my favorable one. So change of base rule is very important. Log with base BA. I change the base completely. Log with base C. It's my choice. And it should be an acceptable base. Right? So log C, A by B. So input divided by your base B. Right? Mostly we will take log or ln. That's what available in calculator. So we can do that. So exponent property and logarithmic property are interrelated. B power x into b power y, b power x plus y. So product goes for addition. Addition goes for product while simplifying, right? Because they are inverse functions. Their property is also kind of maintaining an inverse relation here. And actually it's b power x equal to b power y means then x is equal to y. So we have all the properties interconnected. Exponents and logs are interconnected. Now logarithmic properties and transformation. The properties of logarithms have direct connection to transformation. Product versus vertical shift, power and vertical dilation, structure compression, change of base property, and horizontal structure compression. So product property, log with base bmn, you can write it as log bm, log bn. Okay. So if I have log 2x, okay, and I'm applying a transformation log to 3x. So what is the transformation basically? It's a horizontal compression by scale factor 1/3. Correct. Now I'm going to tell it as vertical shift. How? Log 3x can be written as log 3 plus log 2x. So this is an OG function and a constant is added. So it's a horizontal. I apply like generally, right? The common rule is telling it's a dilation, right? Horizontal dilation. But your manipulation is telling it's also a vertical shift. Yes, it is also a vertical shift. And yeah, so it means log 2x, the OG function is moved this many units up, right? Now, Power property and vertical strength chart compression. So multiplying the logarithm by a constant. So this is the graphical connection, let me tell you. Log 2x square if you have, log 2x you have, and I multiply 2 outside a function. That means it's a vertical stretch, right? Now when you write it, log 2x as 2 log x, log 2, you can write x square. In that way also you can manipulate this. So both will represent the same function. Log 2x square or 2 log 2x, they will represent the same function. And when your modulus of the power is greater than 1, it's stretched vertically. Between 0 and 1, it's compressed vertically. If it's less than 0, if you've got some negative here, we know, right, it's a reflection. Question 1. Approximate log B72 given that log B2 is this and this. Okay, I need to find log B72. So let me take. All I have is my input is being 2 and 3. So we are going to decompose the number 72 in 2 and 3 form. So log B. 72 can be written as 9 times 8. 9 can be written as 3 square, 2 cube. Why I pick? Because I have 2 and 3 to be connected. So 3 square and 2 cube. Now log is in product. So you can do log B 3 square plus log B 2 cube. Now it's 2 log B 3 plus 3 log B 2. Right? And then log B3 value you can plug in 2 times. From here onwards, you can use approximation symbol. 0.6827 plus 3 times log 2 is 0.4307. That's it. And when you simplify all this, you will get, let me quickly check. Mm, 2.6575. So simple calculated calculation. Okay, 6575. This is how the applying property of logarithm help us. Now, question number 2. If log 2 is A and log 5 is B, which of the following expresses log square root 20? So yeah, split the base like square root 4 times square root 5. So it will go log means no base means it's base 10, right? So log root 4 plus log root 5. Log root 4 is 2. Log root 5 I can write 1 by 2 log 5. How? Because this can be written as log 5 power half and power rule we can apply. So we got it. What is log 2? It's represented by A. Plus half log 5 is B. That's a simple manipulation we applied here. Great. And question number 3, the last question. Let x be a real number such that all logarithms below are defined. Which of the following is not equivalent to this? Okay, so all of them have same base. That's a good thing. So log 2, I'm going to combine these. So they will get multiplied x plus 4 into x minus 2 the whole cube. You can't combine directly. So apply power rule, it will go here. Okay, so you got this. And then you can combine because log doesn't have anything in front in both the cases. So this. Then also we have minus log 2 x plus 1. Minus log 2 x plus 1. And this time 2 logs have same base. I will divide the inputs. X plus 4, x minus 2 the whole cube divided by x plus 1. Okay, so let's match the option. Yeah, this is correct exactly as we simplified. This also works because they split the x minus 2 the whole cube into x minus 2 and x minus 2 squared. So this works. And this one is the second step, yeah, which is equivalent. So no, it's not equivalent actually because something is missing here. the cube, right? So this is not an equivalent one. And this one is also not equivalent because it has a 6 here. Okay, which is not equivalent. C and D are not equivalent. Right? So that's the wrap for today's video, and yes, with a bonus question. So here is a bonus question. Take a screenshot, solve it, and give your answer in comment section. Always you can share your feedback with us. We would love to help you. And that's it. Please join student community of Let's Unbound so that you will get more updates on our upcoming webinars and many more newsletters. So thank you so much for joining today. Let's meet in next video very soon. Until then, keep learning, keep practicing, and stay curious.